Good day. Welcome back to yet another session on drawing the free body diagrams and formulating the equation using Newton's second law of motion. So we're having this situation, we're having block A and block B there. So let's read out the statement so that I'll help you to take out the important information there. So two blocks of masses 10 kg and 4 kg are connected with a light inextensible string. So like I said, that once they told you that these objects have mass, it means that they have gravitational force. So this object have the gravitational force and they are connected with a string, so it means that they are having tension and placed on a horizontal surface. So once something is on a surface, we know that it is having the normal force as well. So this we have normal force. When a force of 58 newtons is applied to the 10 kg block at an angle of 25 degrees with the horizontal. So also here we know that there's the force that is being applied but at an angle. The system accelerates at 2.72 meters per square second to the right as shown in the diagram. The 4 kg block experiences a constant frictional force of 2.5 newtons. So these objects that are sitting on the same surface, so it means that this block also has the frictional force. So this object is having 5 forces acting on it. So let's take a look at the 4 kg block and see how many forces are acting on it and also which forces are acting on it. So we talked about the Fg since it is having mass, so this we have the Fg. It will also have the normal force, it is on a surface. It will also have the tension force since there is a string pulling them, and also it will have the frictional force that we are told earlier on. So now how do we draw the free body diagrams of this object? So let's take a look at object A there. So we're having 5 forces, so we can just draw our body like that. We represent it with a dot. So this is our normal force to start with, and we're having gravitational force, which is always straight downwards, and we are going to have the force applied at an angle. So this is our force applied, this is our normal force, and we also have the tension that will go in the opposite direction from this. So this is our tension, and we also have the frictional force. So this is the free body diagram of object A. Now let's try to formulate the equation of motion of this object. Now let's see how we can deal with this. So how many forces are acting parallel to motion? We're told that these are accelerating to the right. So we need the forces that are parallel to the motion. So how many forces are there? We can see tension, it is parallel to motion, and you can see frictional force is parallel to motion. And this force is acting at an angle, and we said that if a force is acting at an angle, it will have components. So this will have 2 components. It will have the F at X, and it will have the F at Y as well. And I've explained this on our lessons on Newton's laws when we're dealing with forces. So now we can see that we're having 3 forces that are acting parallel to the motion, right? So now we can just write our equation as F net is equivalent to MA. So on our F net, we can see that we're having 3 forces. So this is F at X plus tension plus frictional force being equivalent to mass by acceleration. But now let's take the direction into account. So we said the direction of motion, we always give it a positive sign. So anything else that is going in the opposite direction, we give it a negative sign. So now this means that our F at X is positive. So F at X plus minus tension plus minus frictional force must be equivalent to mass by acceleration. This is our equation on this block. So now let's go to the other block. Let's see how we can deal with the other block now. So what do you have in this block? We're having those forces. I think there are 4 forces acting on this block. So let's draw the free body diagram of this. So again, we can have our object, our normal force, which is straight up, and our FG, which is also perpendicular downwards, and we can have our tension there, and we can have our frictional force. So these are the forces, or this is the free body diagram of this object. So now how about the equation of this object? This object, it is also going to the right. So we consider the forces that are acting parallel to the motion. So we're only having 2 of these, right? So we can just represent our F net being equivalent to mass by acceleration. So this is tension plus frictional force being equivalent to mass by acceleration. But now let's take direction into account now. So this is going that way, so that way is positive. So anything that is going in the opposite direction, it should be negative. So now this means that our tension is positive plus our negative frictional force. This should give us mass by acceleration. And this is our equation for this object now. As simple as that. I hope you can see how simple this is, and you can master. So as I explained, once you master how to draw your free body diagram and how to formulate these equations, if you can master how to formulate these equations of Newton's laws, you are done. Like, that is all that you have to do. The other questions, they'll be just as simple. We'll see in our next sessions, we'll be solving the questions. But once you master this, you are okay. I hope you enjoyed, and I also hope that you gained something. If you have, please show us by that like button and also that subscription. Please subscribe. We want to reach 1,000 subscribers as early as we can. Enjoy the rest of the day. See you on the next one.